Hello everyone, my name is John and I'm back with a new video. This is a video of the series where I'm covering Autogluon and I am discussing some broad topics of Autogluon where I'll be using collabs for it and demonstrating how these collabs work. So right now what we'll be discussing is multimodal predictor that can solve problem where the data are either image, text, numerical or categorical forms. So right now in this demonstration, we'll see how we can use two classical NLP problems like sentiment analysis or sentence similarity. And for to begin with that, we will first install Autogluon multimodal. And here are some commands that I ran because it was showing some error for the version. So this will fix the error basically, these three commands. And then we'll use matplotlib and numpy for making the vector array. And so what our task is like we take the data set. Here we are taking Stanford Sentiment Tree Bank data set, which consists of movie reviews and their associated sentiments. Uh, Given a new movie review, the goal is to predict the sentiment that is reflected in the text as in the review. So we'll predict uh, what it is. This prediction will be a binary classification, and where the label will be 1 if it says it is a positive review, and it will say 0 if it is a negative review. So that is our goal. So first we'll be loading the data. So this is the load function for which we loaded using which we loaded the data, and you can obviously do a lot of things. You can show the head of the data, like the first 10 entries for how the data looks like. This is the label. 1 means positive, 0 means negative. So what we're trying to predict is this label uh, feature. So let's move on ahead and see what we have done here. So we are using multimodal predictor where we have given label as label and evaluation matrix as ACC, and we have defined the path where the model will be saved. So this is what we have given to the predictor, and now we try to make fit the training data into that. And we have set the time limit as 180 seconds, so it will take 180 seconds, and in those 180 seconds, whatever it will basically fit and generate, it will give us as an output. So it has done its work. It did its work. Now we need to test the um, prediction. Like we'll be evaluating this. So for that, we use predictor.evaluate, where we test the model using our test data that we downloaded uh, from that link earlier. And now it shows that there is an accuracy of 51%. Or so this is really straightforward, and that is how we can load the model and use for other sentences as well. That is what we're doing here. And let's now move on to the next collab. So in this collab, what we're trying to do is, so people around the world speaks a lot of languages, and according to SIL International's ethnologue languages of the world, there are more than 7,000 spoken and sign languages. So what we're gonna do is, we try to use multimodal predictor again, and this can help us build multilingual models. So we are using this cross-lingual Amazon product review sentiment dataset, which comprises 800,000 Amazon product reviews in 4 different languages: English, German, French, and Japanese. We'll demonstrate how to use Autogluon test to build the sentiment classification for the same. So first we begin with installing the multimodal, and then we'll try to load the dataset. And the column label will be 0 or 1. So 0 being negative, 1 being positive. So let's go ahead. So this is the procedure where it install everything, whatever we need. And now what we are doing is we are loading the data in this from the Amazon review sentiment cross-lingual data set. And now what we're trying to do here is that uh, okay, again, we are loading the data and we are showing what kind of data it is. So these are the columns, how many rows that are available. This is the labels, 0 being the negative one and 1 being the positive one. So this is in the different languages. And so this one looks like a German language, and this one looks like an English language. So we'll try to fine tune the German word. So for this, our approach will be using pre-trained pre-trained by deep set. So what we'll be doing is um, we'll integrate multi-model predictor with the Hugging Face transformers, and we'll directly load the German bird model available in Hugging Face and transformers. So here, that is what we're doing. We're trying to give the hyperparameter as that German-based, BERT-based German case, and just giving the label as label which our data has as our feature, and it will basically do a fit to this predictor. And right now, for here in this, we are not saving the model actually, but once this is done, we can score our prediction. So it shows 84% of accuracy, which is pretty great. And for an English language, it shows 57% of accuracy. So again, it also depends on how much time you give it to run and train the model. So that is it for this collab. We'll move on to the next collab. So this is a name entity recognition. What we'll be doing is it refers to identifying and categorizing key informations from unstructured text. An entity can be a word or a number or a series of words which responds to categories such as cities, and time expressions and some monetary values and like person, organization, etc. So we'll try to find those entities. So this is also a natural language processing problem. And for example, like Albert Einstein was born in Germany. So what we'll try to take out of these entities will be Albert Einstein, which is a person, was born in Germany. So Germany is a location. So we'll try to extract Albert Einstein and Germany. So this is what we're going to do. So first of all, we'll download all the frameworks and everything which we need, which is like Autogluon multimodal, and then we'll try to prepare the data for it. So all you need to do is prepare your data as data tables, like that data frames, which contains a text column and an annotation column. So the next column store the raw textual data, which contains the entities you want to identify. Suppose you want to identify people or person or location, right? So correspondingly, the annotation column stores the label information. Example, the category, start and date, offset in the character level for the entities. So auto AutoMM requires the annotation column to have the following JSON format, and we cannot forget about that. So let's go and look in the code we have here. So that is what we're doing. We want it to be like this. We'll be categorizing in person and location in this one. So where entity group is category of the entity, and start is the character level position, indicating where the entity begins, while end represents the ending position of the entity. So here we took an example for the Albert Einstein. So you can annotate Albert Einstein as a single entity group, or you can also assign each word a label, right? So like just like this, assign Albert Einstein a label as person. So if we are already familiar with the NER task, we you might have heard of beginning inside out format. So you can adopt that format, and let's start with loading the data. So this is how the data will be looking like. So this is how we need to do the entity annotation, and we'll try to extract the entities out of this text snippet. And, so we'll be training the data, we'll be using multi-model predictor again, and we'll try to fit the data and hyperparameterize using Google Electrica small discriminator, which is quite lightweighted. And once it is done, we'll again evaluate our model. So it is a pretty low precision. Uh, However, you can have a higher precision if you specify the presets for the model. Let's say if you want to give it some more time, you can specify that presets should be best quality. So that way you can get a model to predict, with a higher prediction value. Let's go to the another one. Uh, so this is a zero shot image classification. We'll be using Clip for this. This is an open AI model. Um, and you can definitely go and check it out what it basically do by clicking on this link. So first we'll try to uh, before we get started, we'll definitely install every required Autogluon libraries that we need. So that's what we have done here. And then we'll try to load the data from this URL. And once we have loaded the data, we can actually see what's happening here. Uh, it- uh, what we're doing is normally to solve this task, we need to collect some training data from Stanford dogs dataset and train a dog breed classifier. So first we'll be classifying what kind of dog breed it is. But with Clip, all you need to do is provide some potential visual categories, and Clip will handle the rest for you. So that is pretty easy and simple for us. What we'll be doing is we'll be saying that problem type is zero shot image classification, which is this, and give to the multimodal predictor, and it will, and just call this function predict prob, and classify the text with this dog image that this is a husky, this is a golden retriever or German shepherd and stuff like that, and it will give the so clearly, according to the probabilities, we know that there is a husky in this photo. And now let's go and get some more photos where we have an electrical bike over here. And we'll try to predict this as well. This is a Segway, bicycle, wheel, or a car. So it will predict for us what it is. And here is a Apple image. We'll try to predict that out of this Granny Smith iPod library pizza toaster dough, what it is basically. And yeah, this is it's giving iPod. So Clip also has some other limitations, and if you are interested, you can click on this link and see what are its limitations. Now let's go to the another collab, and so this is a image classification quick start. In this, we'll use the task of image classification to illustrate how to use multimodal predictor again. And we are going to prepare our data with pandas framework format, and we'll just do a single call of multimodal predictor.fit that will take care of your model training. So first of all, we'll start with creating an image dataset, and we'll use the subset of Shopee IET dataset from Kaggle. And each image in this data depicts a clothing item and correspond to label specific its clothing category. So our subset of the data contains the following possible labels. It's like baby pants or baby shirt, and women casual shoes, and mobile women chiffon top, something like that. And once you have loaded the data, um, we'll try to train the model, and we'll use again the multimodal predictor function and try to fit the data, and we are setting a time limit to 30. Obviously this will not give a good predictor model, but this is just for the demonstration purpose, so that is why I use this. And once this is done, we can see the accuracy that it is showing 100% of accuracy, 1%, 10% of accuracy. uh, and we'll try to predict this image as well. Like we'll upload this image and see what it is giving as prediction. So now what we'll be doing is extract the embeddings. So extracting represents from the whole image learned by a model. And so it is very useful. We'll provide extract embedding function to allow predictor to return the n-dimensional image feature when n depends on the model. So it is usually 512 to 2048 length vector. And we'll use that for this, and we'll try then save and load the data basically. So we have this one more collab with us for this video. This is going to be the last one. So what we're going to do here is our goal is to fast fine tune a pre-trained model on a small data set in COCO format. So, and evaluate it on its test set. Both training and test set are in COCO format as well. So first of all, we'll convert data to COCO format for how to convert other data sets to COCO format basically. So to begin with, we'll again download the data and we'll provide the OS path to it. So it's a tiny motorbike data, and It's all in the Cocoa format, .json format. So we can use this one. While using like Cocoa format dataset, the input is in the JSON annotation file of the data split. And now what we'll be doing is we'll select, like we'll use the presets as medium quality. So it will generate not a good model, but for I mean, for a demonstration like this, it will be pretty good. So we'll be fine tuning the model now. We'll give the train path and everything where it will store the model. And once this is done, we'll try to print the evaluation as well. So that is all for this video. I hope you learned something out of this. And if you like the video, please care to like the video and subscribe to my channel. Thank you so much.